There we go. So, safety, there's two sides to it. You got the security side and the safety side. The security side is anybody coming in on the equipment from the outside, Trojans, integrity, so on and so forth on that side. And the other side is the actual machine safety for the environment, the people, the individuals. So we've got some laws. These, the PL, which is performance level, that's more over in Europe, but it's coming over here. That's how we rate all our stuff over at Festo. So you got PLA, PLB, PLC, D, and E. And then you can see the categories we were talking about earlier. You got category B, which is not even here in the States that I'm aware of. Category 1, yes, we have that. Category 2, I don't see any of that in the States. I don't know if you guys have ever seen Category 2. It's new to me.
People that don't know what they're doing.
And then there's a lot of Category 3, and then you got the Category 4. And then you got the SIL, which is more on the component side of the stuff and the overall safety of the whole equation. So safety function, you got input, you got the logic, and then you got the output. PL, performance level, is always got to be greater than performance level required. I'm not going to go through all this, but this is just a nice flow chart for risk assessment. You can start at the top, go down through. There's 2 pages of it. The SIL is, you got like 2 channels. You got the S1 and S2. At the very bottom, you can't see it. But you got serious and slight. Slight is S1, serious is S2. That'll pair you into the chart. So you're on the upper rung or the lower rung. And then you've got the frequency. If it's high, low, you go on that rung. And then you've got the possibility of the hazard. You've got P1, P2. And then you go over to the far right, you got upper left is low risk. Go to the bottom, it's higher risk. And of course you go further to the right in the chart right here. So now we're going to get into a little bit of the overall safety function. So you got a safety door, safety switches, you got your safety logic in the center, and then you've got your power switch device, which in this case is showing a valve. But this logic here would be through a safety device. You may be monitoring the spool on this valve. You may monitor the pressure. Most of the time they monitor the spool position. And then you got your actuator, your driver on the outside there. Here's a little couple pages of just showing you the inputs, shows you the logic. At the top, I believe that's showing you 2 inputs. You got 2 channels. You got logic for the 2 channels, and the 2 channels are talking to make sure they're both happy or not happy to not give you an output. The left-hand side there just shows you a bunch of different inputs. The little rectangle in the center shows you basically what's going on in the logic, which I just basically roughly discussed. And then you got the output side. And then we've got a bunch of new, these are unique to, I believe, Festo, these acronyms. STO, which is pretty common in the electrical side of things, but SS1, SOS, and stuff. Performance level, what makes up the performance level? Quantitative on the one side and not quantitative on the other side. And they all come together to make your performance level. Here's a little bit more just talking about more of the MTTF that we're just gonna, here we go. So here's some pneumatic circuits. And what we've got is we've got a valve right here, single solenoid. You've got a pressure, not a pressure bit, you've got a prox here that senses the spool position. This could be a safety device. Here's another one right here, but this is more indirect monitoring, where you're monitoring the pressure on each one of the upcoming ports going to the actuator. Here's an indirect monitoring. You've got proc switches on the actuator. SIL, safety unit, we talked about that a little bit. Here's some more safety. When the first one here is 100, 1 out of 1, you have no safety here. You got one device. This is a single acting actuator up here. There is no safety at all. Here you've got safety. This is 2 of 2, or 2 out of 2, and then you've got 2 valves that have to be on to get a signal out to the actuator. So that's much more safe than the first one. Here is more on the redundancy side, where you got 2 valves and you're gonna have either one on to get the actuator to perform. 2 out of 3, so you've got this valve right here is basically a manual override. So if you turn this valve on, this actuator would change states. Now you've got to have 2 of these on to make things happen, and then you got redundancy here between that valve configuration. So if you had a failure of 3 valves, you would have nothing happening at the actuator. These are more used more in the process world for petroleum and stuff like that than you see in the industrial world. Here's just a little diagram of an air prep going out to an actuator. So what you got is you got a manual shut off here, you've got a filter here, you've got a regulator right here, you've got a pressure switch here, you've got a dump valve which has got looks like a single solenoid on that one, and this unit right here is a soft start. So it brings the air on gradually out to this actuator. So if this was in one state and the cylinder wasn't going to be moving back, retracting, it was going to be extending, let's say, it would extend slow if that valve was active at that time, the yellow valve. So it wouldn't just fly out that way. Here's a bunch of circuits, and we can go through these if you guys want, or we can skip over some, but I'm just going to go through them. So, STO, safe torque off. You got a 5-3 valve. So right now there's no energy on the actuator as long as either one of these solenoids are de-energized. You got the same setup here, but it's composed of 2 valves. So if you want to extend it one way, you turn on one coil on one of the valves. If you want to go the other way, turn the other one on. But you have to turn the other one off before you can turn the other one on to get it to actuate. Where in this valve right here, it's all in the same body. You can try to turn them both on, but if it's sitting one way, it's probably not going to get pulled the other way. Safe stop is another circuit here. So what they're doing here is you got pilot pressure going up to here to shift this valve, you got main pressure going into this valve, you got pilot going over here. So right now these valves are exhausting, these 5-2s are exhausting. So you got to energize those to get this to happen when you energize this valve in the center here. Just a little circuit. Safe stop and closing is another arrangement. Safety limit speed. That was maybe what you were talking about a while back here.
Yeah.
So you got the flow controls here, one. Then you got one here where you can change the speed if you wanted to. It brings it out to this other valve out here. It's exhausting, but you're going to exhaust them both. That's a little different. You see that? Where, yeah. So safety limit torque, safe direction. As I say, I think these acronyms, correct me if I'm wrong, Greg, these SL, like the SLT is unique to us.
I don't know about that.
Okay.
The nice thing about this is you've got circuits already in place if you're trying to solve a problem. You know, and that's really what this catalog is designed to do.
So you got safe stop and blocking, you got safe stop and brake. You got another circuit here they're showing. But you guys are gonna get, if you want a copy of this, we'll get you a copy of the whole catalog. Limited speed and stopping of movement. Vertical axes. So you got PO checks in here. Right here is PO checks, and then you got, it looks like manual overrides here.
The only other thing I'll say, jumping in a little bit too, is because this was designed in Europe, OSHA isn't keen on a couple of like trapped air in a circuit is bad. So typically, like this one with pilot operated check valves, if somebody would get injured on that and they see the PO checks in there where you're trapping air, you probably have some trouble.
Because you got stored potential energy.
Correct, between the valve and the actuator.
When you hit your dump valve, you better exhaust everything.
Right.
So then you gotta start kind of looking at some of that from an American point of view a little bit as well, if that makes sense.
I'm surprised it's the European, it's allowed. Okay, it's good to know, thanks for pointing it out.
But I think you got to do a risk assessment on all the applications. I mean, because some are going to take you to the nth degree, and other ones aren't going to take you on the severity.
Does Europe frown on dumping?
No, they don't. But like in the US, and this is a classic example, so where we're not supposed to have trapped air, like we have options where you can put a brake onto that piston rod that's upside down.
Right here, right here.
So when you dump air, it'll lock. So you're going to mechanically lock it instead of locking it with.
But there's customers here in the Twin Cities that don't want to dump air, so their internal administrative controls are they dump power to the valves. So the valves can't switch states.
And you can.
You can do that.
And
Sometimes they'll do that.
All the trapped air and all the potential energy.
Usually when they're dumping power, they're dumping air too.
No, this customer doesn't want to dump air.
Do they monitor the pressure of the air then?
Hmm?
Do they monitor the pressure of the air? Okay. And then some of them will do external pilot on their valves, and they'll dump the external pilot also. So they got like a little redundancy or another channel, let's say, but it's not truly another channel in the safety world.
They're not. They're just cutting power to their valve bank so they can't change the state of the valve.
Mm-hmm. But the thing is, if that valve failed, because it's not a safety device, somebody's going to be in trouble.
Yep.
If they can prove it.
Just seen it locally.
Mm-hmm. But normally they'll dump it, they'll do 5-3s, and they'll open when it's in the center position. So you kill the power, open, and now you don't have any air trap between the valve and the actuator.
Right. And we talked to me with those.
But yeah, we just got a bunch of these circuits through here. Different brakes. Air prep we talked about a little bit. I briefly talked about it here, and I'll line up. Here's air prep again, just a picture of it showing you what it all resembles from the symbols down below and stuff. So you got manual dump here, you got a regulator here, right, and filter combination. Then you got a pressure switch here. Then you got a single solenoid dump, and then you got a soft start built into the end of it. Here's just some of our product with the acronyms on them. I'm showing you the PL level, PLE, PLD, you know. So we've got valves that can be mounted right out by the actuators, or this and this and this and this right here are more at the beginning of the air preps, the airstream, I should say. Here's some more, just showing you the PLC, is it? Yeah, the C stuff.
So the regulators that you've got that are closer to the actuator, are they tamper-proof? And in stock, they get less than 12 weeks.
We've got tamper-proof ones,
We've
yeah.
got lockable ones.
Yeah.
And in stock, they get less than 12 weeks.
Pardon?
And in stock, they get less than 12 weeks?
Yes.
Okay.
Another thing you want to remember, when you put a actuator or a regulator between the valve and the actuator, it's nice to have that check built into it.
Okay.
So the air, when you're exhausting, goes around the regulator, so it's not back driving the regulator. Our regulators can go either way, depending on what series it is.
Sure. Yep, so the exhaust around it.
Right.
Okay.
And if you have a check around it, usually you get a little more performance out of it, speed-wise.
Okay.
And like that one that's on top is one that you can actually build into a manifold. For like that pressing application that we were showing not too long ago with the rod going down. That one you can build into our VTSA and it'll actually take in reverse. If there's a safety breach, it'll actually retract.
So yeah, it doesn't just stay there. It goes
And this one
There's
has
a couple
got
different ways of,
monitoring on it too. We're monitoring the school.
right.
There's proxies standing up on that. Some more PLC stuff. PLC level, performance level C. Actuators down here, we've got rod lock. So there's a rod, there's a little detent in it, it drops down in there. So you can have them on the rod end, and some of the series, I think you can get them on the cap end also.
So you can get them on both.
Yeah. Here's a rod clamp right here. We should just jump to the other page here. The catalog shows this stuff in a bigger picture. Here's the same thing as we were just talking about. Safe direction. There's a couple different configurations of those.
Professor, because you had the rod lock and the clamp, is the rod lock available for most of the actuators, or is it?
A lot of them.
Okay.
Yeah.
But if it's not, then you can put a clamp on there? That's
You
good.
can put a brake on there. The rod locks are great if you're already retracted and you lose air. The problem with those is if you're mid-stroke and you lose air, they don't do any good, right? Because there's no detent there.
With our ISO cylinders, you can order an ISO cylinder with an extended rod on it, and you can slide the brake onto the end of the.
That's where you'd use the brake.
Yeah.
We're talking about.
We've got some valving. It's safe. It's zoned. We've got it in Profi safe right now. We're working for SIP safety for Rockwell. We're working also for on the EtherCAT side of things. It's on the roadmap. It's going to be a while out yet. Another couple of years, I think. A year and a half, 2. But the VTSA, we've got, if you need safety, we've got safety manifolds, but it's in Profinet, which is Profi Safe with Siemens. We've even got inputs and outputs for that. They're so-called true safety. You can see the zoning going on here. There's like 3 zones in this one. It's broken off on the pages, but you can see it, the zoning going on. In this manifold setup, you can even put a saw start at the beginning if you want to energize the whole manifold. So there's options. And that's it. So how do I get to the next one? Right here is the next one. This is just going to show you guys a little bit of the spattering of product we've got. Break this down just a little bit. So here's our MS air prep. We've got, this is a category 3 here, which is a performance level D. And then this one is category 4, all self-contained with the switches and everything else. And it's a performance level E. You can, with this one right here, you can get to a performance level E with that by adding another switch to the side of it. But all the safety logic is outboard of that, external, where the E is all built in. So you just tell it on, it does all the monitoring for you. If it's not happy, it just doesn't come on.
You've got a lot of people use that to upgrade an existing machine. They didn't want to put the time in the programming. They can just buy that, make it category 4.
And another thing I didn't mention here, these all got soft starts built into them. You can get them with or without. But most of the time, when you go to this level, the soft start is put right in there. This is a chunker valve on and off, lockout, tag out
And that's
valve.
OSHA approved.
Yep. Here's that, there's a rod lock here.
So it just
Clamp.
bolts on the other cylinder, okay?
Yep,
Bolts in line with the body.
Yep.
exactly. Yep, right here.
You just need a rod extension, so when you're ordering it, make sure that you accommodate for it.
Yeah. This is some of the
That's
VTSA
a
we were
better
talking
picture.
about.
Yeah.
So you got the valves here, they got the proxies on it for monitoring, which we talked about a little bit earlier. This could be in a manifold. This is standalone here. These have got N position locking on them, so right here, when it gets back there, it locks in. It's a little detent in there, so it holds it there. I mean, it's not going to hold the whole load of force, but it'll hold what the actuator is capable of handling. Here you can see the rod lock here, another style. And then you got VTSA manifold, again talking about the safety.
It's a pneumatic clamping unit.
Pardon?
That's on a rodless cylinder,
Yeah,
so
This-
that's a brake for a rodless cylinder. It allows you to clamp that the same way you would with that rod brake up on the rod type.
Yeah, right here.
yeah.
Now you're clamping it on the rail on a rodless.
This has all been discontinued, right, Greg? This stuff right here?
Yeah, it could be.
Yeah, I think that's been just thrown in on this slide. It's 2003, isn't it? Yeah.
And the other nice thing about that VTSA stuff that you see up there that we're talking about with the VTSA manifold, that's perfect for if you've got like a pressing application. The rest of the machine, nobody can get injured on, but it's only the single press part. You can build that in, then you don't have to take and dump air to the rest of the machine or anything else if they can't get injured. And you can build it into your valve manifold and be done.
So
And it'll
you,
meet category D or E.
so you build it into a zoned manifold,
Correct.
Yeah, you could do that.
or you just have a separate one for that?
Or you just have a separate block. This is a separate block.
So it's another way to kind of approach that, you know, without limiting the rest of the machine.
Yeah. Right, which alleviates a lot of, I mean, because the customers I hear that don't want to dump air, it's just because they've got so many machines on their plant that they all dump air upon each stop, they are worried about the air can recover quick enough.
Yeah.
Whereas you can limit that by just going to the most hazardous of the application.
So like I said, one of these blocks for that is specifically designed for pressing, and will actually just make sure it tracks, right? So you can't get injured that way.
Yeah, it's just that there's sometimes you don't want any movement at all after stop. After.
Right.
Yeah.
Yeah, you don't want to traverse them back.